So this is Algebra 1, Semester 2. It's the 4th unit called Exponential Functions, and this is a bonus section called 6.5 Bonus. It's on CreatorMath.com under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find the site on Google. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. Before we get to the actual problems, I want to take you and show you where the notes are. This can be difficult for students to find, but hopefully once you find it once, you can get back to it. Here's the name of the website, right? CreatorMath.weebly.com. If you Google that, hopefully you can get to this page. All right, looks like this. If you have any questions on the composition book, please scroll down under that picture there, right, till you find the words composition book. Please just read all the directions, watch all the videos, follow all the due dates, and put everything on the right pages according to the directions with the notes, which we are going to go to now. The notes are under the tab for the course. In fact, not just notes, but the page numbers on which the notes go, the problem sets, the videos like we're making now, and, of course, the vocabulary. If you're not getting 100% on your vocabulary practices, you may not know that there is an entire PDF of every vocabulary word we will use for the entire school year. Right here, you can download it to your device, and it is searchable. Just Google, how do I search a PDF with whatever type of device you're using. It is a little bit different per device, so just follow their directions. Next, we're going to find the semester that's important to us, or the one we're in. You're going to make sure to copy this table of contents in full. It's about 3.5 pages long, under pages 2 through 6 of your composition book. Why is it so important? Because it has the page numbers of where everything goes for the entire semester. Now we're going to go down to the unit we're in. So here's the unit we're in, exponential functions, and each of these is a lesson within that unit. We are in lesson 6.5. It's this bonus one. It's way down here. Okay, so it's under this bonus section way down at the bottom here. Bonus video solutions and bonus problems. These don't technically go on any pages. You could put them on these scratch work. See this scratch work practice pages here? You can put that on these. Please don't use this video for the page numbers, but go back and find the table of contents at the time you're viewing this. All these page numbers could have changed, you guys. So just know to find this table of contents and not use the video for the page numbers. Well, so that means we may have to pull up notes from prior lessons because this bonus is an assemblage of problems from those prior lessons. Okay, there we go. This one starts out with given the following data for global population growth. 1960, 1.5 billion. 1990, 3 billion. So let's just stop right there before we get too far into the data. 1960 to 1990, how many years is that? 30 years' time. Okay. What's happening to the number of people on Earth? 1.5 billion to 3. 2x. You follow me? It's doubling. 2 times 1.5 is 3. So now let's go again. Let's go 1990. Here's the next set of data. 2020 is 6 billion people. So is this 30 years apart? Yes, this goes to 2000 and then to 2020. This is, again, a 30-year jump. And what can we expect? The 3 is going to 6. Look at that. Okay, so this is now going another 2x, right? The 3 was doubled to 6. So what will be the population in 2050? So now we're going again from 2020, right, to 2050 is 30 years, so another jump. It doubled every 30 years prior, so we're going to assume it's going to double that next 30 years. So we went from 6 to 12 billion people, okay? Pretty big jump, and 2050 is not that far away, right? So crazy. Just to think about the population of the Earth, the number of people on the Earth going to such vast numbers. All right, given the following data for global population growth, all right, this looks like the same data. So 1960, 1990, 2020. Now they're jumping all the way out to 2080. So we did 2050 in the prior problem, and we said it was going to be 12 billion. Fair enough. So now we're going another 30 years into the future. So what do you think we're doing with the population? We're doubling again to 24 billion. Okay, so by 2080, 24 billion. Now the thing you might ask yourself is, how old will you guys be? If you're listening to this right now and you're one of my students, how old will you be in 2080? That's 60 years from now, right? So say you're 15 right now. 15 plus 60 years, you'll be 75 years old. You could see 24 billion on Earth by the time you're an older person, right? I know it's hard to imagine yourself as being 75 years old, but it happens, you guys. It happens quicker than you can imagine. So that's something interesting for your brain to think on. Given the following data, all right? Now, they're going even, so then we went to 2080. That was the last one, right? Now we're going another 30 years in the future. So now we're going to jump all the way up to 48 billion at 2110. Now, that's 30 years out. Will you guys make it to be 105 years old? I don't know if you will, but you might, because they're constantly pushing on expanding the amount of years that a human can live, right? Through medical innovation and through better living and healthier living and that kind of thing, right? So you may see, if you could live to 105, you may see 48 billion on the Earth. Given the following global data, okay. Now they're just asking, here it is. They're going 1960, 1.5. They're going through the whole thing. 1993, 2026, 2050, 12, 2080, 24. By the way, this is a linear, this is an expansion of 2x per 30 years, right? This could either slow down, like we could have a global, let's say we had a global war or something and killed off a lot of humans on Earth, right? This could shift drastically down. Or let's say it accelerated. Let's say we went through some kind of change where now all of a sudden, instead of people having one baby, they had 6 babies at a time, right? Through different, I've seen some sci-fi movies where that was the premise, right? And then all of a sudden these numbers just expand even more than they are. So they're asking, with each 30-year jump, the growth is doubling each period 2 times. So with each 30-year jump, how much is it going? It's doubling. It's being multiplied by 2 times. Right, given the following data for global growth, boom, what is the equation that represents this? Well, because we're starting with 1.5, that's our starting point, we want to see a 1.5 here. So the standard for exponential growth and decay is AB to the caret x, all right? And you might say f of x equals AB raised to the power x. This one here is the starting point. We started at 1.5 billion, so hence the 1.5. Then we're taking 2 to this power, right? So however many years we're going out, that's the way this thing is going. So we're going to circle this one here. All right, and remember, this is the 3rd lesson or 4th or 5th, I forget. It's a bonus lesson. So this goes back through the other lessons. If this doesn't look immediately recognizable to you, you'd go back through those other lessons first, right? Given the following data, here it is again. What will global food production be in 1950? Okay, so given the following data for global food production, so now we're switching. We were dealing with population. Now we're dealing with how much food humans can produce. In 1960, we could produce enough food for 1.6 billion. In 1990, we could produce enough for 4.7 billion. In 2020, right now, we can produce enough for 7.8 billion. What will be the global food production in 2050? So we're going 2020. These are 30 years again. So this is 30 years. This is 30 years. This is 30 years. So we're going 30 years at a time now again. Okay. How much do we increase? We went 1.6 to 4.7. All right. So what's the difference between that? And you might even go back and say, let's just go, right? Let's just think about this a little. Keep your calculator out. 4.7 minus 1.6. 4.7 minus 1.6. Okay, 3.1 I see is the change in food production ability. 3.1 billion change in those 30 years. Then we went, okay, from 4.7 to 7.8. What's 7.8 minus 4.7? 3.1 again. All right, so it looks like we're adding 3.1 billion in food production every 30 years. All right, so if we go, what will the food be in 2050? So we went from 7.8, add 3.1 to it, we get 10.9. So 10.9 billion will be our ability to produce food in 2050. Now they're going to 2080, so add another 3.1 to it. So 14.0. Now we're going to 2110, 17.1, okay, which is 14 plus 3.1 is 17.1, right? So now we're talking about food production. So now they're talking about this. Let's see what's happening here. Okay, given the global food production is these numbers we just talked about, how is it increasing? Growth is increasing by 3.1 billion each period, okay? This is a beginning at 1.6 and a 3.1 times the number of years, right? This is y equals mx plus b, otherwise known as a line, right? Which of the following equations produces a line? So this one produces a line, and they're encouraging us to use desmos.com to check this out, right? So let's go back to Chrome, to here, to here. Let's start with the food production, right? Food production is y equals 3.1x, 3.1x plus 1.6. Okay, and the numbers are in billions, right? This is 3.1 billion is added each year in food production. It started at 1.6 billion. Now let's put in the second equation. All you do is tap here, get another bracket, and say y equals, now we're going to do the 1.5 times parentheses 2 to the power x. 2 parentheses power x. Okay, there it is there. Let's try to, will it show me this? All right. Expand this? I can. Here's what I'm interested in, two things. This point and this point. Okay, and let's go to the next problem before we look at this too much further. And of course, this is not algebra 2, this is algebra 1, right? So they're not going to make us do too much with exponential functions, like equation solving and things. We've done a tiny bit. But basically speaking, we're focusing on the big picture ideas of what's going on here. Given that food production is linear, and human population is exponential, what is the eventual outcome of this trend? So here's an actual, they're not even, we graphed it. We know what the graph looks like. Here's the population, right? Going like this. Here's the food, going like this. The point is food is linear. Linear. It's a line. The other point is that population is exponential. It accelerates. In other words, it started slower here, right? But as more people get here, the reproduction rate starts to expand. It's just like the spread of a virus, right? An exponential curve is a virus curve. So there's a couple of important points here. We're crossing each other here, and we're crossing here, otherwise known as intersecting or hitting points where the solution to both of these equations are the same, but after that, both the exponential and the linear equation have the same answer right here, but after that they change, and before that they're different, right? So if this is food production and we're here, do we have enough food to feed all the people? Yes. Okay. Here, do we have enough food to feed all the people? Yes. But what happens up here, folks? Here the food is here, and the people are up here. Here's the food. It's below the people. Oh, come on. Sorry about that, you guys. I always do that. Here's the food, low. Here's the people, higher. This gap here represents the difference between the amount of food we have to feed people and the amount of people on Earth, right? If the growth of people is exponential and the growth of food production is linear, which may or may not be true. Now that would be a bigger discussion of whether that's true or not. We are not going to have enough food to feed everybody in 2110. All right? So that's the bigger point, and maybe why this stuff is even important in the first place. What good is math? Well, this kind of math is pretty good, because if we can't feed people, we need to start thinking about that right now, right? And they are. They've done a lot to think about how to re-engineer crops, etc., which has its own ethical questions involved with it. Anyway, without getting too far into it, right, you can go down the discussions later, and we'll have those later. This is just the math portion. Make sure you're matching up the title of this video with the title of the problem sets you're doing. This is Algebra 1, Semester 2. It's the 4th unit called Exponential Functions, and it's a bonus set of problems called 6.5 bonus. All right, hope that helps.